Today we are going to see about the basic ER concepts in the database management system. In the ER concepts, main thing is the ER model. In ER model is also defined as the logical representation of our data for an enterprise. So we are representing the things data present in an enterprise in a logical representation so that it will be very easy to design a database. So it was developed to facilitate the database design by allowing the specification of an enterprise schema which will represent the overall logical surface of a database. Here the ER model is a top-down approach to the database design. So here we will represent the logical representation of the database of an enterprise so that it will be easy for an designer to create a database. In the ER model, the basic things we need to know are the entities, relationships, attributes, and the constraints. The entities are nothing but the objects that we are used in a user interface, which are the distinct objects. Then the relationship is nothing but the meaningful interaction among the objects we are used in the database. Same way, the attributes is nothing but which will describe the entities and relationships. Each such attribute is associated with a value. So each entity and relationship will have several attributes. Then each attribute will have a specific value for it. We can take the value from its value set. Then next one is the constraints. So we can apply the constraints on the entities, relationships, and the attributes. So these are the basic things we are using in the entity relationship model. We will see each one separately in detail. Before that, we are going to see about the symbols we are using in an entity relationship diagram, that is ER diagram. We can use a rectangle for representing the entity set. So simply a rectangle we use, it's nothing but an entity set. Then for representing the attributes, we can use an ellipse. Then next we can use a diamond for specifying the relationship between the entities. Then we can use the lines for linking between the attributes, relationships, etc. So the lines are nothing but the link attributes to the entity sets and the entity sets to the relationship sets. So we can use lines to connect between them. Then next is the double ellipse. So ellipse is used for specifying the attributes. So if we use a double ellipse, it is used to specify the multi-valued attributes. If an attributes have more than one values, we can represent it by using the double ellipse. Then next one is the dashed ellipse. So dashed ellipse is nothing but the derived attributes. If an attribute is derived from some other attributes, then we can specify it using a dashed ellipse. Then next, then other one is the double rectangle. So double rectangle is used to represent the weak entities. So we have first specify about the rectangle. So the rectangle will use to specify the entity set. If the entity set is a weak entity, we can mark it with a double rectangle. Then another one is the double line. So the total participation of an entity in a relationship set, we can use it by you can mention it by using a double line. So if we are drawing an ER diagram, we can use these symbols to mention the entities and attributes. So for rectangle means it specifies the entity. Ellipse means it will specify the attributes. Diamond means it specifies the relationship between the entities. Then line is used to link. So same things we can use with a double ellipse, the dashed ellipse, double rectangle, and double line. So if it is a double ellipse, then it is a multi-valued attributes. If it is a dashed ellipse, it is a derived attribute. Then if it is a double rectangle, then it is a weak entity set. Then double lines, it will use to specify the total participation of an entity in a relationship set. So these are the symbols we will use in drawing the ER diagram. Then next, now we see in detail about the entity. So entity is nothing but an object or a thing in a real world with an independent existence, and that is distinguishable from the other objects. So entity is nothing but an object or a thing. By its name, we can distinguish it from the other object in the real world. For example, it may be a student, it may be a things like place, etc. can be an entity. An entity may be an object with a physical existence such as person, car, house, employee, or city. So example example of an entities is a person. So the person may be a student, patient, employee, doctor, or engineer. So we can represent anything as an entity in the database. For example, if we use a place as an entity, we can specify the city, country, or state inside the place. Same way, if we take event as an entity, the event may be a seminar, sale, renewal, competition, etc. We can mention it as an event. Then next one is the object. If the object, if we specify an object as an entity, the object may be a building, automobile, machine, furniture, toy, etc. Then if it is a concept, if you specify the entity as a concept, it may be a course, account, training center, work center, etc. So anything we can represent as an entity. For that, we can create a ER diagram and we can represent it in an ER model. For example, if we specify student as an entity, same way college as an entity, in the student may contain student ID, student name, student address. Same way the college is an entity, the college will contain a college ID, college name, etc. So this is a sample ER diagram for representing an entity. Here the student and the college is an entity. We are specifying the student as we have used the rectangle. So the rectangle is used to specify the entity. The student here, the student is an entity. So here the student is an entity. Same way here college is an entity. Here we have used a rectangle to represent the entity. This is a sample here taken. The next one is the entity types. So that entity can maybe we can represent the entity in two ways. One is the strong entity, then other one is the weak entity. If an entity type is that is not dependent on some other entity type, then we can call that entity as a strong entity. So if an entity that's value it's not dependent on any other entity, we can specify it as a strong entity. Same way, an entity that cannot be uniquely identified by its own attributes and it relies on the relationship with other entity, we call it as an weak entity. So an entity, if it is dependent on the other entity's relationship, then we can call it as a weak entity. So that we can represent the weak entity by a double rectangle. So previously we have seen about entity. So entity that is a student, college, etc. They are all strong entities. So we have represented it with a rectangle. So we can divide the entity into two types, strong and weak. If an entity that does not depend on any entity, then we can specify it as a strong entity. So we will specify the strong entity with an rectangle. If an entities that values or its attributes depends on the other entities relationship, we can call it as a weak entity. So we can mention or we can represent the weak entity by a double rectangle. So for example, this is an example of an weak entity and the strong entity. Here the bank is a strong entity because it will depend, it is not dependent on any other entity. It will be standalone, but the bank account is an entity which will depend on the bank because if there is no bank, there will not be any bank account. So bank account is a weak entity. So we represent the, so since bank is a strong entity, we represent this with a rectangle, but bank account is relies on the bank, so it will not function separately without the bank, so it's a weak entity. So we represent it with an double rectangle. So with the diagrammatic representation itself, we can identify which is the strong entity, which is a weak entity. So if we want to draw a diagram, we want to consider whether the entity is strong or weak. If it is strong, we can use the rectangle. If the entity we are using is a weak entity, that is it's dependent on other one, we want to draw it with a double rectangle. Then next comes the attributes. So the attributes are nothing but that will describe the properties of an entity. Here we have an attribute describes the property of an entity. An attribute is represented as oval in the ER diagram. Since entity is represented as a rectangle, attributes will describe the property of an entity. So we can represent the attributes with an oval symbol in the ER diagram. So attributes can also be divided into 4 types. So there are 4 types of attributes: key attributes, composite attributes, multi-valued attributes, derived attribute. So again, once again we see about attributes. So attributes will describe the property of an entity. We will represent the attribute in an oval symbol. There are 4 types of attributes: key attributes, composite attributes, multi-valued attributes, and the derived attribute. So the key attributes are key attributes. So key attributes is nothing but an attribute that can uniquely identify the entity. So we have seen about an entity. If an attribute which when it uniquely identify an entity, we can call it as a key attribute. For example, if there is a student entity, we can uniquely identify a student by his or her roll number. So the roll number is a key attribute. Same way, a student may contain several attributes: name, age, address, phone number, etc. But the only thing we can uniquely identify the student is the roll number. So, so the roll number is a key attribute. So we have seen about the attribute is nothing but which gives some additional properties to an entity set. So the key attribute is nothing but an attribute which can uniquely identify an entity from an entity set. So in this student entity, the roll number is a unique number, so that we can identify a specific student by this roll number. So for example, student roll number can uniquely identify a student from a set of students. Then the key attribute is represented by a oval, same as other attributes. So as we have seen, attributes for representing an attribute, we have specified the oval symbol. Same way, key attribute is also represented by the oval, same as the other attributes. However, the text of the key attribute is underlined. So here we can see that roll number is underlined. Name, age, and address are not underlined. So we can know that roll number is a key attribute. So key attribute means an attribute which can uniquely identify an entity from an entity set. For example, student roll number can uniquely identify a student. So the key attributes is also represented by the same oval symbol as the other attributes, but the text inside the key attributes is underlined, so that we can identify that particular attribute is a key attribute. Next comes the composite attribute. So composite attribute for consider this example: student, address, then pin code, state, country. This is an example of the composite attribute. An attribute that is a combination of other attributes is known as a composite attribute. For example, the student will have an attribute called address, but this address will be combined, get by combining some other set of attributes. So if an attribute that is a combination of some other attributes is known as a composite attributes. Here the address of the student is nothing but pin code, state, country, etc. When we combine all these only then we can get the address. So we can call address as a composite attributes. For example, in a student entity, the student address is a composite attribute, as an address is composed of other attributes such as pin code, state, country, etc. So when an attribute which uniquely identify an entity means we will say as a key attribute. Same way, when an attribute which is a combination of other attributes, we can say it as a composite attributes. Next one is the multi-valued attributes. So an attribute that can hold multiple value is known as a multi-valued attributes. So for example, if a student have a phone number, so the phone number, a student can have more than one phone number also. So an attribute which can hold multiple values is known as the multi-valued attribute. So to represent it, we can use a double ovals in an ER diagram. So just an oval is an attribute. If we use a double circle, it is a multi-valued attributes. So a person can have more than one phone number. So the phone number attributes is a multi-valued attributes. It's represented by a double oval. Same way, this is the key attributes. So this is the example of a multi-valued attribute, that is the phone number. Next one is the derived attribute, and derived attributes is one whose value is dynamic or derived from other attributes. For example, if you say that attribute is an derived one, that value is dynamic, that is it will be changing frequently or after few months or few days or few depending on the time, then we can say it as an derived attribute. So the derived attribute is a one whose value is dynamic and derived from other attribute. So it's represented by a dashed oval in an ER diagram. So as in the previous page, here we have represented the ages in a dashed oval. So here age is an derived attribute. So in, for example, person's age is a derived attribute as it changes over a time, and it can be derived from another attribute, date of birth. So depending on the date of birth, the age of a person will be changing. For example, last year if we have get a person's age, it then after 1 year it will be +1. So that it's changing depending on the date of birth as the time changes. So an attribute whose value is dynamic, that is it changes, it is not permanent, it will be changing and is derived from some other attribute. We can say it as a derived attribute. It is represented by a dashed oval. For example, person age is a derived attribute as it changes over a time, and it can be derived from an other attribute, date of birth. So as in the previous example, the student first one is the student ID, it's a key attribute. Then student phone number, it's a multi-value. Then age, as it's represented by a dashed oval, it's an changing or dynamic attribute. So it's represented as an dashed oval as it depends on the date of birth for its value. So it's a dynamic attribute or a derived attribute. So this is the example of all the types of attributes. So for a student can have a student ID, date of birth, age, student name, student phone number, etc. Here is a key attribute. It's a dynamic attribute. Again, a student phone number is a multi-valued attribute. Next one is the relationship. So relationship is nothing but how the entities are related with each other. So when a single instant of an entity is associated with a single instant of another entity, we can call it as an one-to-one. So there are several entities. Some of the entities may relate with some other entity. So if a single entity is associated with a single instance of another entity, we can call it as an one-to-one relationship. So the person, then passport. So person is an one entity, passport is also in another entity, but a person will can have only one passport and and also a passport can be given only to one person. Not same passport cannot be given to a more than one person. So we can say it as a one-to-one relationship. For example, a person has only one passport and the passport is given to a one person, then we can call it as a one-to-one relationship. So the relationships is nothing but the communication between the entities or the association between one entity and then another entity. When a single instance of an entity is associated with single instance of another entity, then we call it as a one-to-one relationship. For this, the example is person and a passport. The only one person can have a passport. Same way, only one passport can be given to a single person. So this is the example of one-to-one relationship. Then next one is one-to-many relationship. When a single instance of an entity is associated with more than one instance of another entity, then it is called as one-to-many relationship. So when a single instance is associated with more than one instance of another entity, we can call it as a one-to-many relationship. That is, a customer can place more than many orders in a company. So, or he can purchase many items in a company. So, a single customer can have many orders. So, this is an example of one-to-many relationship. For example, a customer can place many orders, but an order cannot be placed by many. So, single order cannot be placed by many customers. So, this is a one-to-many relationship. One-to-many relationship example. So, customer with an order. So here it can be only one customer, but the order can be many, but it not be reversible. So this is a one-to-many relationship. Next, many-to-one relationship. When more than one instance of an entity is associated with a single instance of another entity, then it is called many-to-one relationship. So when more than one instance related to a single instance of another entity. So that's a reverse of a previous one-to-many. Here many-to-one. Then it is called a many-to-one relationship. Here there is only one. There are many students. There is only one college. So many students can study in a one college, but there can't be a but there can't be one student in many colleges. So this is a many-to-one relationship. So when more than one instance of an entity is associated with a single instance of another entity, we can call it as a one-to-many. So here is students means many instance. Many students can be studied in a single college, so one college. So this is a single instance. So for example, many students can study in a single college, but a student cannot study in a many college at the same time. So single student can't study in a many colleges at the same time. So this is the many-to-one relationship example. Next one, many-to-many relationship. Here, when more than one instance of an entity is associated with more than one instance of another entity, we can call it as a many-to-many relationship. So, as the previous one, here we take a student as one entity. Here there can be many students, and we are assigning a project to the many students. So, in a single project, there can be any number of students. Same way, same students can also be assigned to any number of projects. So, this is a many-to-many relationship. So, many-to-many relationship is nothing but when more than one instance of an entity is associated with more than one instance of another entity, then it is called as many-to-many relationship. For example, a student can be assigned to many projects and a project can be assigned to a many students. So this is the example of the many-to-many relationship. So finally, we summarize all the things. So we are going. We have seen about the ER basic ER concepts. So for the basic ER concept is used for representing a logical representation of a data in an enterprise. So it's used for the representing this ER model will help us to in facilitating the database designs. So then again, this is a top-down approach for the database design. Here, the things we are used in ER model are the entities, relationships, attributes, and the constraints. These are the symbols we are used in the entity relationship model. Rectangle for representing the entity set, ellipse for representing the attributes, diamonds for representing the relationship sets, lines for linking the entities and attributes in the entity to the relationship. Then the double ellipse for multi-valued attributes, dashed ellipse for derived attributes, double rectangles for weak entities, double lines to participation of an entity in a relationship set. So the entity is nothing but an object or a thing in a real world that is distinguishable from the other object. It may be a physical existence such as person, car, house, etc. Same way, person means student, patient, employee, engineer, etc. Same way, we can represent various entities, place, event, object, concept, etc. So the representation of this entity can be done with an rectangle as like the student and college. Then there are two types of entities, strong, weak. When it is not dependent on any entity, we say it is a strong entity. When an entity dependent on attributes of other entities, we call it as a weak entity. So we can represent the weak entities in double rectangle and strong entity with a single rectangle. Then attributes are nothing but that describes the property of an entity. So we represent the attributes with an oval symbol. There are 4 types of attributes: key, composite, multi-valued, and derived attribute. Key attribute is nothing but an attribute which uniquely identify an entity. So nothing but a register number of a student for distinguishing a student. Then composite attributes means combination of other attributes. We call it as a composite. Example, address. So the address will depend on other attributes. So we can say it as a composite attributes. Then the multi-valued, if and where attribute may contain more than one value, we call it as a multi-valued attributes. Example, phone number. Your student can have more than one phone number. So we represent it with a double oval symbol. Then derived attribute, if a value of an attribute is dynamic and it is derived from some other attribute, we can call it as a derived attribute. It is represented by a dashed oval. This is an example of the representation of different types of attributes. Next, the relationship. The relationship between attribute can be 4 types: one-to-one, one-to-many, many-to-one, and many-to-many relationship. So we can represent one-to-one relationship, that's a single instance of an entity associated with a single instance. We can call it as a one-to-one. A person can have only one passport and only one passport can be given to a single person. The next one is one-to-many relationship. If a single instance of a entity is associated with more than one instance, we can call it as one-to-many. That is, customer can place any number of orders, but only one order can, same order cannot be placed by more than one customers. Then many-to-many, if more instance of an entity is associated with single instance, we can call it as many-to-one. Same way, many-to-many means more than one instance is associated with more than one instance of another entity, we can call it as a many-to-many relationship.